So let's look at a few problems from chapter 19 now. The first is an aldol condensation. Now these reactions form a new carbon-carbon bond, and they can be done in either acidic or basic conditions. So what we have here is basic conditions, so we're going to have OH. And the first step that we do is a deprotonation. So you see that now we have carbon with a lone pair and also a molecule of water. So now what we do after this step is we add in another carbonyl. In this case, I'm going to add in, I'll put it in red so we can see the different structure. I'll add in that aldehyde. Now the lone pair of electrons right here will attack this structure. So now we're going to combine these two molecules into one, and it will look like this. So you can see that the new bond that we formed, this bond right here. Okay, so at this point, we have an O-. That is going to get protonated by the molecule of water that we formed after the first step. So I'll redraw the water right here. Take a pair of electrons and steal an H. Now, we would stop here if we did not have heat in our reaction, but most of the time you're going to see heat. So when we have heat, we're going to go forward and create a double bond between the two carbons that join together, and it would look like this. So we're going to take the OH that we just formed from up here, from that water, and you're going to steal one of these H's on this carbon here, throws electrons onto that carbon. And then the last part is to eliminate this water by taking these electrons, throwing them down to make a double bond here, which kicks off the OH. Okay, now I have drawn the cis form here, but this is more likely to be trans because it would be more stable. So how about we just make it trans instead? So this is your aldol condensation product. Now let's take a look at an example of an intramolecular aldol condensation. So if we were to add in OH minus and heat, this can occur, and in the first step we'll get a deprotonation at the alpha carbon, which is the carbon bonded to your carbonyl. So I'm going to draw in OH right here. And if we take one of these pairs of electrons on OH, we can steal one of these H's away from the alpha carbon. This carbon now has a pair of electrons because remember, when you steal an H, the bond between the H and the C falls onto the C. So that's where we get this lone pair here. Okay, now this is the point where we have the ring forming step. So we see that this carbon is far enough away from this carbonyl that these electrons can attack and make a ring. So that is exactly what's going to happen. So we take this lone pair, goes all the way around, attacks this carbonyl, pushes electrons up. So we have a 1, 2, 3, 4, 5 carbon ring. So I'm going to draw up my 5 carbon ring down here. And then this red arrow is going to be a bond between these two carbons. Let's call that this bond right here. So now if we call this top carbon the one that attacked, it does not have an O on it, but it has an H. And then it also has a bond that goes to this aldehyde group here. So let's draw that in right here. Now this carbon down here is the one that we attacked. So this one has now an O minus on it. And the H. And then the rest of these carbons just have 2 H's on each. Okay, now at this point, we're going to do another deprotonation. So if we put in another molecule of OH minus, what happens is we end up deprotonating this H right here. Now this is the step where we can form the double bond. So before we do that though, we need to do one more thing which I had forgotten about here, and that's with this O minus. So what we have to do is we have to protonate it. So you can use a molecule of water to do that. So we'll just pretend that we had protonated this, and then we don't have to redraw the whole structure for another step. So to deprotonate, we're going to steal this H. That will push electrons onto this carbon. And my bad, instead of an H here, we just deprotonated that, so this is now an electron pair. So once we have this with the OH down here, which again I messed up, it's better. Now we can form that double bond. And the way that that happens is just like what we did before, and that's bringing this electron pair down to form your double bond, and that kicks off an OH. And this is your final product for the intramolecular aldol condensation.